Welcome back, everyone. My name is Shaun Levick from the Geospatial Ecology Remote Sensing Lab. Today we continue with our introduction to remote sensing. The topic of this series is image classification, and we're on to part 4 now of image classification, where we're looking at supervised classification. In the last video, we generated these training areas, shown here in our Worldview 2 image, collected over Darwin City, Northern Territory of Australia. If we want to view these, make sure you've clicked into the image and that it's highlighted. Don't think I showed you last time. There's a little icon up here, Show Hide Geometry Overlay. That will switch these training areas on and off. And also over on the right-hand side, we have the Layer Manager. If you come in here, you have the ability to switch various training areas on and off in the display. Now, what we've done is we've collected these training areas, which represent homogeneous areas of the scene of different land cover types. We're now going to use this information to run a supervised classification. So let's go up to Raster, Classification, Supervised Classification. The first one we'll run is a maximum likelihood classifier, a very common statistical approach for classification, assigning pixels to the class of maximum likelihood. What we need to do is click on the image name. We can use this icon here to add it to our product set. And note we have 3 tabs: product set, classifier parameters, and the output. So this is where we're going to write it to. We're adding ML class onto the end. And now under the maximum likelihood classifier, we need to open this dialog up. Train and apply classifier. We're making a new classifier. If we had one already developed, we could load it here. We're going to train our classifier on vectors. Vectors are the polygons that we have digitized on screen. It could also have been data that we've imported from a GIS in shapefile format. We're going to leave these settings as default. Importantly, which vectors will we use for training? Let's highlight all of them. We're going to use all of these classes. And which bands will we use for classification? Again, we select all of them using the Shift key. That means we'll use all bands in the analysis. Then we just hit the Run button. I've already generated it, so that's why I need to overwrite it. You just say OK. And the process will run. We have a progress bar down the bottom, computing raster data. You see the percentage done. This will take a little while. And then when it completes, you will see a notification at the bottom. Processing completed, in this instance, 86 seconds. This is running on a MacBook Pro. And you'll see that a new product is added to our product explorer called Worldview 2, and it's added that ML class onto the end. So let's close the interface and have a look at our classification result. To do that, we need to look at the bands folder of the product, and you'll see labeled classes. Double click that, and that'll open up the classification in a new window. Having a quick look at that, doesn't look too promising at a first cut. We see the ocean in purple, and we also see a lot of purple in urban areas and over the airport. Let's just have a look at the color mapping though, using the next to navigation, the color manipulation tab. We have all our classes listed here. We have colors assigned to them and their frequency of occurrence in the image. Now this is just a random mix, and there's lots of purples in here, so it's quite hard to see actually. So let's recolor these to more meaningful, intuitive colors. So for water, I'm going to go with the blue. Mangroves, I'm going to go green. Dense vegetation, let's also go with a darker green. Savanna, say orange. Sports fields, I'd like a lighter green for that, something like that maybe. Buildings, let's go red for buildings. Tarmac, black. Bare soil, and let's have a look at this. Immediately we see some problems, particularly with regard to our buildings class. If we were to believe this, we have buildings in the ocean, and so clearly there's some confusion in this classification between buildings and water. What else can we see? Have a closer look. Spend some time moving through the image. It seems to have picked up these big dense trees pretty well, but I'm also quite surprised that we haven't picked up the mangroves very well. It's picked up these threads, but we would have expected to do a better job in these areas. Now, we haven't run a validation here to test the accuracy, but we can intuitively see that we're not happy with this result. So we have a few options. One is to add in ancillary data to use. We could bring in an elevation layer, for example, which would certainly help removing any confusion as to where the ocean is. We could pull in or calculate NDVI to strengthen the vegetation component. We could also add more training data by selecting more areas and being more careful in our selection. Remembering that in our buildings class, if we go back to analysis, statistics, select the red, the near infrared band 1 here, use ROI masks, buildings, refresh. Remember, in our buildings class we had this double peak, and that's never a good thing. It indicates that this should indeed be split into two classes. So that's the one option, would be to refine our training areas, but also maximum likelihood. It's very common, but it's not a very advanced technique. So before we go back to training areas, let's try a more sophisticated classifier. Raster, classification, supervised classification, random forest classifier. Now, clicking on the help button will bring up the help menu, and this is important because it has more descriptions on the different types of classifiers and where they originated from. And just briefly, random forest is a classification and regression tree technique invented by Bryman, and that paper is published in Machine Learning. It's called Random Forests back in 2001. Random forest randomly and iteratively samples the data and variables to generate a large group or forest of classification and regression trees. The classification output from random forest represents the statistical mode of many decision trees, achieving a more robust model than a single classification tree produced by a single model run. So it's an iterative machine learning process. The interface is basically the same. We need to select the band that we want, the image that we want to classify, add it here. Just be careful, we only want to classify the original image. If the machine learning result pops up here, you can remove that using the minus icon. Write, we're going to write it with the underscore RF that's added by default. And then this interface is the same as the previous one. Train and apply a new classifier. Let's leave these default values. We won't evaluate it now. We'll do that in the next exercise. Train on vectors. we want to make use of all the sample data we've collected. Feature band selection, we want to make use of all the bands we have available. So we hit run. I'm going to overwrite a file. If you haven't run it before, it won't pop up with this question. And that process will run. Again, we have a progress bar down the bottom here. And that might take a little bit longer than the previous one. And of course, if I predict that it'll take longer, it ends up taking shorter. So this ran faster in just 44 seconds. So we can close that now. And let's go back to the Product Explorer. Let's minimize these images that we have available. So this is our original image. Number 2 is the maximum likelihood result. And number 3 is our random forest result. If we expand that, look in the bands, labeled classes, double click, that'll open up in this new image window. And again, the colors that are randomly assigned are not very useful to us because they're very similar, difficult to visually inspect. So let's change them to more meaningful colors. Let's go blue with water. And immediately we see a much better result for the water classification in that we don't have this separation we have, and we don't see water going into the urban environment or into the airport. So immediately we can see that this has produced a much better result. Mangroves, let's pick a dramatic pink for mangroves so that it's easy to see them. And again, this looks more promising, certainly picking up a lot more mangroves than the first classification did. Dense vegetation, let's make that dark green. Savanna, orange. Sports fields, light green. Buildings, red. Tarmac, black. Bare soil, that color. Maybe we can find a better brown for bare soil. Something in the swatch, something like that. Okay. And then let's maybe just change that savanna to yellow, and that should be easier to interpret. Now, as we have a look around, I think we've certainly done a better job with the buildings, shown in red here. I'm going to click on the hand so I can pan around. We see mangroves covering these fringes. Savanna is kind of an other class. It was everything that was left over. Here we have some buildings surrounded by dense vegetation. Sports fields seem to be well picked up. We see a bit of that in the urban environment too. That could be people's lawns. So sports fields, probably a bad name. We should just call that short grass. So we head over to Cullen Bay. Nice distinction in the water. This level of detail, we're not distinguishing between boats and buildings. But in general, from a purely subjective visual point of view, this looks like a much better classification. We have the runway coming out nicely in black, and these statistics for the land cover distribution look much more reasonable. Just a reminder that if we want to compare these two, let's close and split the window vertically, tile vertically. As long as we go back to navigation, check that these two icons are highlighted. As we move through the image, we can compare the different classifications. It's actually good to use the same color schemes. So what I'm going to do is save the color palette from our random forest to a text file, and we'll call this RF Darwin. Save it. And now when I go to our original classification, that's in the top image here, I can import it. RF Darwin. So now the advantage of this is that both these color scales are exactly the same, so it allows easier comparison. So now we can compare these classes. Let's start in Darwin, Charles Darwin Nature Reserve, and in this bottom image, which is the random forest results, we can see certainly that we've done a much better job with the water and the mangroves. And as we come through this little industrial area, much more detail and a lot more accurate. Here's the airport. So in general, we would be much happier with the random forest results than that maximum likelihood results. Of course, we could still refine this further, adding additional training data, adding ancillary data sets could improve this even more. And so far our evaluation here has been purely subjective. It looks reasonable, and the random forest approach is certainly encouraging, but we need to put hard numbers on that. So in our next exercise, we will look at accuracy assessments and developing error matrices. So that will go very much more into the validation of classification results. So thanks for your time, and see you in the next tutorial. Cheers.